All right, let's talk about some common features of functions. These are things that you should recognize in a function and be able to describe with proper notation. Okay? Every function has a y-intercept as long as x equals 0 is in the domain. Okay, so if x is allowed to equal 0, then there is a y-intercept of some sort. In this function, the y-intercept happens when x is 0, so it happens at the point 0, 2, right here. Okay, and we're going to state our y-intercept as a point. It is the point 0, 2. Okay, the x-intercepts of the function happen when y is 0. So the x-intercepts happen here and here. There we go. All right. So our x-intercepts happen at, I gotta count it at 1, 2, 3, 4, 5, -6, 0, and at 4, right? 1, 2, 3, 4, 0. Okay, we also write our x-intercepts as points. There's another name we've given to x-intercepts. We call them roots, or we call them zeros. And we will be calling them both of those things in this unit, okay? Over the interval -1 to 2, is f of x increasing or decreasing? And how can you tell? Well, I got to figure out where the interval -1 to 2 is, all right? And this, we're talking about x values, and you can see because they use x, all right? So when x is between -1 and 2, what's happening to my function? All right, well, my function is doing this. So we say that the function is increasing on that interval, and it is increasing because it is going up from left to right. All right, so you're always looking from left to right, and it is going up from left to right. Same graph. Now I want to say, I want to give the interval over which f of x is greater than 0. All right, well, the line where f of x equals 0, it has another name, and that's called our x-axis right here. Where is the function greater than 0? It's greater than 0 anywhere it's above the x-axis. So it starts being above the x-axis right here, and then it's above, 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 and then it stops being above right there. Okay, I'm interested when we are greater than 0 and not equal to 0. So I'm going to give my x values accordingly. So I'm going to say that I start being greater than I start being greater than 0 when x is -6. Okay, but I'm not allowed to be equal to -6 because then I would equal 0, and I'm not allowed to equal 0 right there. Okay, so x has to be greater than -6, and then I'm greater than the x-axis all the way until this point when x is 4. All right, but again, the function equals 0 at 4, so I'm not allowed to include 4 in the interval. When I'm talking about where the function is greater than a number or less than a number, I'm always giving the x values where that is true. Okay, here I gave it an interval notation. Here I gave it an inequality notation. I could also give it an interval notation from -6 to 4, not inclusive. Okay, state all the x coordinates of the relative maximums and relative minimums. We can do that, no problem. A relative maximum is the highest point around. So I'm going to use a different thing here so I don't have to. Okay, so relative maximum is like right here, and your endpoints can also be relative maximums. So see how this is sort of the highest point in the area? I would say that those are your 3 relative maximums, and we're going to state the points there. All right, our relative maxes maximums are the points 1, 2, 3, 4, -4, -4, 6, 1, 2, 1, 2, 3, 4, 5, 7, 8, So 2, 8. And then this endpoint we can double as a relative maximum. 2, 3, 4, 5, 6, -2 is also a relative maximum. Put him over here. Now be careful, these look like they're in interval notation, but these describe points and not intervals, okay? They are the points of the relative maximums, and a relative maximum is just the highest point in a given area. It's not the highest point overall, okay? The highest point overall is this guy, and we call him the absolute maximum, okay? The absolute maximum is also a relative maximum, okay? The relative minimums, let's do a different color, are the lowest points around. So this guy and this guy are my relative minimums. Relative minimums. So those 2 points are -8, -4, and -1, 1. Okay, both of those are relative minimums. The lowest guy in town, the lowest point on the function. Oh, I missed one. This guy is your absolute minimum. Do you see where I missed another relative minimum? Okay, my other relative min is right here. All right, at the point 1, 2, 3, 4, 5, -2. So let's include 5, -2 in our list here. I'm going to squeeze them in here. 5, -2 is our one that we missed. So I have 3 relative minimums. One of those is an absolute minimum. Okay, so we just did that absolute minimum on the last page, but let's go ahead and remind ourselves. This was the absolute minimum, and then this was the absolute maximum. So we wrote those down on the other page. The domain and range. Since there are no arrows, I'm going to assume that this is closed and this is closed for the purposes of this conversation here. The domain goes from left to right, and I'm doing this in interval notation. So the farthest left I go is right here, which is -8, and that is closed. We're going to include it. And I go all the way out here to 6. My domain goes from -8 to 6. My range goes from bottom to top. So this is the lowest point that I hit, right? So -1, 2, 3, 4, -4, and we're going to include that. It's a closed circle there. All the way up to my absolute maximum, which happens at 1, 3, 4, 5, 6, 7, 8, -4 to 8, and that is also closed. Okay,